A very good morning, afternoon to respected chairs and participants. My name is Pei, and today I'll be presenting the work Enhancing Recruitment Selection Process in Human Resource with Artificial Intelligence Powered Resume Parser. As you know that human resource is a vital division in every organization, as they're responsible for hiring and managing employees. But the traditional recruitment process is slow, costly, and subjective, and often leading to poor hiring outcomes. With the growing demand for skilled employees nowadays, organizations now need more efficient, fair, and automated recruitment system. So you can think of like a company that needs to hire 100 people quickly, and if their HR staff must manually read through thousands of resumes sent in, the projects can delay for weeks. And this doesn't just waste time. It directly impacts the company's productivity and even market competitiveness. So, the current recruitment system faces three major challenges. First is the manual resume screening that is time-consuming and resource-intensive. Second is the delay in hiring that causes financial loss and reduced competitiveness. And third is the human evaluation that introduces biases and inconsistencies in candidate selection. Hence, this has proven the need for an automated resume screening system that will ensure accuracy, fairness, and efficiency. So, as this is not just an HR problem, this is a strategic business issue. When companies hire slowly, they may lose their top candidates to their competitors, and when they hire with bias, they may miss out on the diverse talents that will bring in innovation. So this automation is about addressing these real-world problems. In this study, we have worked on three areas, which is one, to develop an AI-powered resume parser to automate part of the recruitment process, to compare the performance of 6 different machine learning models for job categorization, and to provide a practical new HR solution with bias reduction. From the literature, we can know that traditional recruitment involves multiple steps, like screening, tests, interviews, etc. While through this approach, it is slow and also resource heavy. Resume parsing systems have been studied as a way to automate this process, and many may use NLP techniques like name entity recognition, NER, to extract structured information, and it has a promising near human accuracy that ups to 87%. So by using machine learning for classification and also NLP for text extraction, we aim to support decisions with more consistent and transparent result. So it is important here to stress on that AI here is not about replacing the HR professionals. Instead, it helps to actually reduce the repetitive work such as the initial resume screening stages, and that decreases the human workload so that their HR staff can spend more time on interviews, evaluation, or even strategic initiatives. For our dataset, we have 2,484 resumes from 24 job categories that is collected from Kaggle. Initially, the data has some challenges, like especially class imbalance, where categories like IT were dominant, or others like agriculture were actually underrepresented. In order to prepare the data, we have cleaned the text, removed the HTML tags, and also special characters, converted it to lowercase for normalization, and uses the TF-IDF factorization for feature extraction. Then, the smooth is actually applied to handle the class imbalance. For example, like without smooth, the model could become biased and predict most of the resumes as IT jobs, simply because it is just that the category dominates. By balancing the dataset, we give minority categories a fairer representation, which is especially important in real HR cases where specialized role exists. We have tested 6 different models, such as logistic regression, naive Bayes, random forest, support vector machine, multi-layer perceptron, and also XGBoost. We have performed hyperparameter tuning using grid search CV with cross-validation to optimize the performance. And after the comparison, XGBoost has shown the best performance, even though other models like random forest also perform reasonably well. We have also tried sentence bed embeddings for a richer text representation and also to improve the contextual understanding. But in our case, the TF-IDF with XGBoost gave a better result instead. In addition, we have also built a custom NER model to extract information such as candidate names and skills. For example, in this test case, you can see that the model correctly extracts Tansuki as the name and identified the skills like Python and machine learning. So this steps adds like a practical value because it actually organizes the resume into a structured information that the recruiters can quickly use. For this table, it summarizes the performance of all the models tested. While random forest achieved a 68% accuracy and logistic regression with a 64%, XGBoost clearly outperformed them with a 77% accuracy. This table also shows the comparison of the sentence bed embeddings for the top two performed models, but the performance is relatively lower. For the IOC curve, it shows a strong discrimination with an AUC value between 0.88 to 1 for most categories. One detail noteworthy that is that the performance was not uniform across all job categories. Like IT and finance performed very well, while smaller categories like agriculture and automobile were weaker. This actually reflects on the real-world hiring challenges, where specialized roles are harder to classify due to fewer examples. And to conclude, we have developed an AI-powered resume parser that combines XGBoost for classification with a custom NER model for information extraction. And the results suggest that AI can make recruitment more efficient and consistent while still leaving the final decisions to human professionals. And in the future, we plan to expand the data set to cover more job categories and languages, and to refine the NER models to handle more complex resume formats and structure, and also to explore a fairness-aware model to further reduce biases more. And that is all from my presentation. Thank you very much.